Welcome friends. Today we will start the first chapter of our syllabus, Introduction to Industrial Instrumentation. What is instrumentation? Let us know it. The process in which assembly of several electrical, measuring and control instruments are interconnected for measuring, analyzing and controlling the electrical and non-electrical physical quantities, that is called as instrumentation. So once again I am repeating, the process in which assembly of several electrical, measuring and control instruments are interconnected for measuring, analyzing and controlling the electrical and non-electrical physical quantities, that is called as instrumentation. So this definition I will give in a notes. There are different types of instruments such as electrical instruments, electronic instruments, mechanical instruments, and instrumentation is further classified into many types such as industrial instrumentation, electronic instrumentation, then mechanical instrumentation, and their classification also we are going to see in this chapter. So, what are the typical applications of industrial instrumentation that we will see now? Military and aerospace systems, there also instrumentation is used. Then heavy construction engineering, there is application of instrumentation. General industry applications, there is also instrumentation is used. Environmental engineering, then automobile and consumer market, laboratory test and scientific studies, and medical and biological systems, weather data and measurements, and data communications. So these are the general applications in instrumentation engineering. Now let us see some of the typical applications in the instrumentation engineering. So typical applications I have listed out here. So first you can see the measurement of system parameters information, then control of certain process or operation, then simulation of system conditions, then experimental design studies, then performing various manipulations, then testing of materials, maintenance of standards and specifications of the products, verification of physical scientific theories and quality control in industry. Now we will see these parameters one by one. What is measurement of system parameter information? So that we will see now. The measurement of system parameter information, that is one of the important functions of the instrumentation is to determine the various parameters or information of the system or a process. Again I am repeating, one of the important functions of the instruments is to determine various parameters or information of the system or the process. In addition, they present the desired information about the condition of system in the form of visual indications, registering, recording, monitoring, suitable transmission according to the needs and requirements of the system. For example, a pressure gauge fitted on a steam boiler drum that gives the visual indication of pressure of the steam. Again I am repeating this example. A pressure gauge fitted on a steam boiler drum, it gives the visual indication of a pressure of the steam. Further, the deflection of the pointer of a speedometer monitors the speed of automobile at that moment. Again I am repeating, the deflection of pointer of speedometer monitors the speed of automobile at that moment. So again the potentiometric type of temperature recorder gives the printout of instantaneous values of temperatures with respect to time in the form of printout. In addition to that, a condition based system of operation is being used very widely these days in the number of situations like medical care of patients or the maintenance of machine systems where shutdowns are costly or prohibitive. So, in short, we can say the measurement of system information, it consists of measurement of different parameters, recording of different parameters which are required to control the different operations of system. Now, the second typical application, that is a control of a certain process or operation. We have to control a certain process, we have to control a certain operation. That is another important measuring instrument is in the field of automatic control systems, that is called as ACS. So measurement system forms an integral part of such systems, which in turn provides deliberate guidance or manipulation to maintain them at a set point or to change it according to preset program. So in the detail we are going to see in the further part of the chapter how process is controlled by measuring different parameters, that we are going to see in a further part. The concept of any control system that requires the measured discrepancy between the actual and desired performance. Again I am repeating the statement. The concept of any control in the system requires measured discrepancy between actual and desired performance. It may be noted that an accurate control of any physical variable in the process or an operation, it is important to have accurate measurement system. The accuracy of control system cannot be better than accuracy of measurement of the control system. I am repeating this the statement which is very important. The accuracy of the control system cannot be better than accuracy of measurement of control variable. So for example, you can take the thermostat fitted in the domestic refrigerator is a control device for maintaining the temperature in the specified range. Currently ACS, that is automatic control system, is widely used process in industry like oil, refineries, chemical plants, then textile mills, etc. So for controlling variables like temperature, pressure, humidity, viscosity, flow rate and other relevant parameters, we use a measurement control system. So furthermore, they are also used in modern sophisticated systems like autopilots, then automatic landing of aircraft, then missile guidance and radar tracking systems. So these are the common applications that comes under the control of certain process or the operation. So but important statement that we have to record here, that is the accuracy of the control system cannot be better than the accuracy of measurement of control variable. So you must focus and think on this statement. Then next typical application, that is a simulation of system conditions. This is also one application of instrumentation, simulation of system condition. Now let us see what is it. Sometimes it may be necessary to simulate experimentally the actual condition of complex situations for revealing the true behavior of the system under different governing conditions. I am again repeating, we have to concentrate on the true behavior of the system under the different governing conditions. So there are some controllable parameters, there are some non-controllable parameters, and there we have to focus. So we have to simulate such parameters experimentally, and we have to observe the actual process. So there we have to go for the simulation of system conditions. Generally, a scale model may be employed for the purpose where similarity of the significant features between the model and full scale prototype are preserved. So we have to use scaled models. Instead of going for actual model, we can use a scaled model, and we can govern the different measurable parameters which are controllable and which are non-controllable. The lift, drag and other relevant parameters of aerodynamic bodies are usually obtained by testing the models in the controlled air stream generated in wind tunnels and that simulate the flow conditions experienced by aerodynamic bodies. So in the aerodynamic bodies, we have to measure the forces like lift force, drag force, and other relevant parameters such as air resistance is there. So such parameters of aerodynamic bodies are usually obtained by testing the models in the controlled air stream generated in the wind tunnels. So sometimes it is not possible to do the experimentation on the site. So therefore we form the scaled models, and these types of nowadays these types of simulations are done by using some CAE softwares, some softwares related to computational fluid dynamics, and there such simulations of different systems are done, and performance of these parameters are also tested. Now next typical application, that is the experimental design studies. This is the fourth typical application, experimental design studies. So experimental design studies, the design and development of a new product generally involves the trial and error procedure, which generally involves trial and error procedure, and that generally use the empirical relations, some handbook data, then the standard practices mentioned in the design codes. You might have learned this subject, design of experiments, DOM, that is called as a design of experimentation and research methodology. There we go for the testing of different controllable and non-controllable parameters, and we go to the form empirical relations. So there also we need instrumentations, and we need accurate data of measurement. So this is one application. In spite of this, we sometimes have to resort to experimental design studies to supplement design and development work. For example, a design team of experienced aircraft designers put in a number of years of effort to produce prototype aircraft. Actually, if you want to do some experimentation on aircraft, aeroplanes, design team that takes many years for just forming prototype model of that aircraft. That prototype model aircraft, it behaves actually. So there we have to take lot of efforts for measuring the different parameters of actual prototype of that aircraft. Then the prototype test data is then used to improve further the design calculations, and modified prototype is produced. So that data is used for modification in the design. So obviously you have to go for vast number of experimentation, and then you can go for the modification of that prototype. So this is carried on the till desired design calculation. We have to modify the design again and again, but for the modification we need accurate data of measurement, then and then only we can go for the success of the design. So thus experimental design studies are often play an important role in the design and development of new products. Now let us switch over to the next typical application to perform various manipulations. So in a number of cases, the instruments are employed to perform operations like signal addition, subtraction, multiplication, division, and differentiation, integral, signal, linearization, signal sampling, signal averaging, then multi-point correlation, ratio controls. There are a lot of things are there. We have to use the instruments for measuring all these parameters. I have mentioned the list of all these parameters in the notes. You can take from there and you can read in detail. So in certain cases, instruments are also used to determine the solution of complex differential equations or other mathematical manipulations. Instruments are also used for determining solution of complex differential equations or other mathematical manipulation. So instrumentation is also used there to solve the differential equation, to solve the mathematical manipulations. We need the instruments also. So a simple pocket calculator is an example of mathematical processing in instruments. A simple pocket calculator that we use daily in engineering calculation, that is also an example of mathematical processing. You can solve different integral equation, then differential equations, then different trigonometric operations you can do in the calculator. This is also an example of various manipulations. Further, we can say that the modern large memory computers are also instruments that are capable of varied types of mathematical manipulations. So for example, you can use the MATLAB softwares that performs different types of mathematical operations. It is also called as an instrument which is used for the measurement. Then the next type of typical application, testing of material, maintenance of standards and specification of products. Again I am repeating, testing of materials, maintenance of standards and specification of products. See, most countries have standard organizations that specify material standards and product specification based on extensive test and measurement. So these organizations are meant to protect the interest of consumers. Rather, they ensure that the material or the products meet the specified requirement so that they function properly and enhance reliability of the system. So here we have to improve the reliability of the systems, and there we need the instruments. So for example, again I am giving the example of aircraft. So aircraft engine is subjected to extensive endurance test by the civil aviation authorities as per the specification before it is certified to be used. Lot of experiments are done, rather I will say endurance tests are conducted on the aircraft engine before it is used. So this is one typical application. Then verification of physical phenomena or scientific theories, there also instruments are used. See, all these points I have mentioned in the notes, you can see in the detail. Quite often the experimental data is generated to verify the certain physical phenomena, and in addition experimental studies play an important role in formulating certain empirical relations where adequate theories does not exist. So for example, a number of empirical relations for the friction factor of turbulent flow in pipes have been formulated till date by various investigators, and which is based on hypothesis in which numerical constants have been evaluated from the experimental data. So, furthermore, experimental studies may be motivated by the hope of the developing new theories, or discovering new phenomena, or checking the validity of certain hypotheses which may have been developed using some simplifying assumptions. So there are lot of scopes for verification of scientific theory. I have just discussed here example of friction factor of turbulent flow, and lot of experiments are also done. So you can go for testing of different scientific theories by using instrumentation. And the last typical application, that is quality control in the industry, which is very important nowadays. Quality control in the industry. Now let us see this point. It is quite common these days to have a continuous quality control test of mass produced industrial products. This enables to discover the defective components that are outright rejected at early stages of production. Consequently, the final assembly of the machine or the system is free from defects. This improves the reliability of the product considerably. For example, a boiler plate has to undergo a number of control tests before it is put in actual operation. The various tests, which are like X-ray examination of the plate for defects like blowholes, cracks, then metallographic examination for metallurgical defects, and the periodic strain test of sample. So these kind of tests are done for quality control of the different products in the industry. So we have discussed some typical applications of the instrumentation. Now let us see the functional elements of a measuring system. There are basically two functional elements. First one is a basic functional elements and auxiliary functional elements. Now which are these basic functional elements? So basic functional elements are those which form the integral parts of all instruments. Again I am repeating, which form the integral parts of all instruments. They are transducer element, then signal conditioning or intermediate modifying element, or data presentation element. These three are the basic functional elements. First one, it is a transducer element, then signal conditioning element, and then data presentation element. So in the basic functional elements, what is this transducer element? So transducer elements that senses and converts the desired output into a more convenient and practicable form to be handled by the measurement system. Once again I repeat, the transducer element that senses and converts the desired input to a more convenient and practicable form to be handled by the measurement system. Then signal conditioning, this element, it is used for manipulating or processing the output of the transducer in suitable form. It is used for processing the output of the transducer in a suitable form. And then the third functional element, basic functional element, that is data presentation of the element, which is used for giving the information about measurand or measured variable in the quantitative form. It is used for giving the information about measured variable in the quantitative form. So these are the three basic functional elements which are there in a measurement system. Now let us see the auxiliary functional elements, which are the three basic auxiliary functional elements. So auxiliary functional elements are calibration element, then external power element, and feedback element, and microprocessor element. These are the four auxiliary functional elements. So what is calibration element? So calibration element is used to provide a built-in calibration facility. It is used to provide a built-in calibration facility. There should be increase in accuracy of the measurement. Output that should be near to the input. So therefore we have to increase the good calibration facility so that we can increase the measurement accuracy. Then external power element. So external power element is used to provide electronically regulated power supply for the working of one or more elements like transducer element, signal conditioning element, the data processing element, or feedback element. Then feedback element, next, third auxiliary function element, feedback element. It is used to control the variation of physical quantity that is being measured. It is used to control the variation of physical quantity that is being measured. So in addition, the feedback element is provided in null-seeking potentiometric or Wheatstone bridge devices to make the automatic or self-balancing. You might have learned these things in the third year of your engineering. That feedback element, how it is important. It is used in null-seeking potentiometer or Wheatstone bridge devices to make the automatic or self-balancing. Then the last, microprocessor element. It is used to facilitate the manipulation of the data for the purpose of simplifying or accelerating the data interpretation. It is always used to conjunction. It is always used in conjunction with analog to digital converter, which is incorporated in the signal conditioning element. So these are the four auxiliary functional elements which are used in the measurement system. So these things are also I have mentioned in the notes. You can go and you can read in the depth.